So now that we have solved 3x3 systems using the substitution technique, right, let's go now use the elimination technique. Either way, it requires a lot of organization, so make sure you keep yourself organized, and then this is going to create some new notation that we will use when we start using matrices. So it's kind of a good, kind of a good step in that direction, but we'll try using our algebra right now. So again, the goal is to go from a 3x3 system to a 2x2 system. All right, but we have a tough choice here because when I'm using elimination, I got to decide which variable I want to eliminate, and then I have to start eliminating values. So I'm going to go ahead and choose Z, and what I now need to do to be consistent is pick which one of these Z's do I want to use to get rid of the other two. So once you make that decision, by the way, it's called a pivot, right? Stay with that pivot. Don't start getting yourself, don't change course. Make your decision and run with it. All right. So what I'm going to choose is let me put a little red asterisk on it. I'm going to use this Z to get rid of these two Z's in equation. As a matter of fact, this is equation 1, this is equation 2, and this is equation 3 as well. So I'm going to use the Z in equation 1 to get rid of the Z in equation 2 and 3. I did not have to do that, right? I could have chosen this one and got rid of these two, or I could have chosen this one and got rid of these top two. Or I could have come over here to this X and used this X to get rid of everything up here. So you can do whatever you want. You have 9 choices, right? Just be consistent once you get there. So since I'm going to be using this Z to get rid of these Z's, one thing I see right away is these guys are already opposites. So to track what you're doing, right, here's some new notation. I call it equation math. What I'm basically going to do is take equation 1, the first equation, and simply add it to equation 3. That's going to get rid of this Z that I want to get rid of. So this looks like 2x minus y plus Z equals 5, 3x plus 2y minus Z equals negative 1. So the Z's cancel out. We're left with 5x plus y equals 4. All right, so I'm going to write this off to the side here because you notice I'm well on my way to getting a 2x2 system. All right, so 5x plus y equals 4. That's what happens when I use this Z to get rid of that Z. Right, so what about the next one? Well, the first thing we see is that they're not opposites, right? This is 2 and this is positive 1. So what we can do is take equation 1 and multiply it by negative 2, right? That'll force that, but I have to make sure everybody gets multiplied by negative 2, not just the piece I want. And then I'm going to add that to equation 2, and that's going to give me the result I need. So following my equation math, I got to take equation 1 and multiply everybody by negative 2. So that gives us negative 4x plus 2y minus 2z equals negative 10. Adding equation 2, x plus y plus 2z equals 4. So the z's cancel out. The x's, we have negative 3x plus 3y equals negative 6. Here I kind of, just to help myself out later, I noticed that everybody, right, if I divide everybody by negative 3, we end up with x minus y equals 2. Okay, so again, I can multiply or divide anything I want to both sides and still have a true statement. So what I've done is I went from a 3x3 system to a 2x2 system. And we got lucky here because in solving this 2x2 system, right, elimination is really nice. If I eliminate the y's, right, boom, boom, we end up with 6x equals 6. Divide both sides by 6, and already we have x equals to 1. And at this stage, how about we just do some back substitutions? So come to this equation here, right? If x minus y is equal to 2, this means that 1 minus y is equal to 2. I'm substituting what I know for x. So subtracting 1, we get negative y equals 1. Dividing by negative 1, we get y equals negative 1. So I now know what x and y are. X is 1, and y is negative 1. All right, so now we got to go find z. Well, if we continue with this back substitution idea, right, I can plug these values in any one of these equations and be done with it. So how about I choose that one there? X plus y plus 2z equals 4. So x is 1, y is negative 1, and so these cancel out. 2z is equal to 4. Divide both sides by 2, and we get z equals 2. So what's the ordered triplet that solves this system? 1, negative 1, 2. It's what we call a consistent system, by the way, and it's also independent. All right, I should have mentioned that in the last videos. I realized I didn't. It's consistent and independent because nobody depends on anybody else, right? X is 1, y is negative 1, and z is 2. So there is a solution making me consistent. It's independent because those values, nobody depends on another value to create its value. All right, so that is how you solve a 3x3 system using elimination. Find yourself a pivot, right? Or excuse me, find out which variable you want to get rid of, right? Use a pivot to get rid of the other two. Use some equation math to keep yourself organized. Once you give that 2x2 system, you just can keep eliminating. And then once you find one value, I did what's famously known as back substitution. I just go kind of back through my story and substitute what I know to find values that I have. That might be the easiest way to do this, but and clearly you can see you got to keep yourself organized. All right, so let me do another example coming soon. I'll see you guys in the video real quick.